Hi, today we'll understand the concept of a modular node in a single linked list. What is a modular node? A modular node is defined as a last node in the linked list whose index is divisible by a given number k. Here, indexing is one based, meaning first node is at index 1. So let's consider a linked list, say 1, 2, 3, 4, 5, 6, and 7. And we were given k as 3. Okay. So we should find the indices divisible by 3. So let's first write the indexes. So 2, 3, 4, 5, 6, 7, since we are using one based indexing. So we should find the indices divisible by 3, and those will be 3 and 6. Okay. So one important observation is that we do not stop after finding the first valid index. We continue traversing the list because a larger divisible index may appear later. For example, 6. Okay. So to find the modular node, what should we do? What should we be doing? Firstly, we should traverse the linked list once, and while traversing, we keep track of the current index. And whenever the index is divisible by k, we simply update the answer to the current node. And by updating the answer every time the condition is satisfied, the stored node at the end of the traversal is guaranteed to be the last valid modular node. And also about the edge case, where if no index is divisible by k, then the modular node doesn't exist. So the answer should be -1 in that case. And for instance, if the linked list uses zero based indexing, right? Like right now we are using one based indexing, right? So instead of one based indexing, if the question asks you to implement this with zero based indexing, we simply adjust the condition by checking index plus 1 divided by k. So this approach requires only one traversal of the list. So the time complexity is linear and the space complexity is constant. Now let's look at the coding part. All right, now let's quickly implement this. We have defined the function to find the modular node, like def modular node, which takes in head and k. First, we got to handle the edge cases where the list is empty or k is invalid. If head is none, or in the case where k is less than or equals to 0, in such cases a modular node cannot exist, so we simply return -1 in that case. Okay. Now, since we are following one based indexing, we start with index 1. So index is initialized to 1. Let's also define a variable which is initially initialized to none. So this particular variable will store the last valid modular node. So let's say result is none. Okay. Now we got to use a pointer to traverse a linked list, right? So we got to initialize current to head as well. Now we got to traverse the linked list node by node. So this is the actual traversal logic. While current exists, okay, while current exists, like also if current is not none, at each node we check whether the index is divisible by k. That is, if index modulo k is equals to 0, like if it is divisible, then we update the modular node as result is current. Okay, and we simply move to the next index, index plus equals to 1. Next, we also move to the next node, that is current dot next. Okay, now after the traversal, if no modular node was found, then we should return -1. So if result is none, we simply return -1. Otherwise, we return the data of the modular node. So if modular node exists, then we return its value. That is, we simply return result dot data. Okay. Now let's go ahead and run the code. So as you can see, for the given test cases, we got the outputs for the modular nodes for each linked list here.